Inequations is what we're going to start with. So what is an inequation? Well, it's simply a problem where we're trying to find possible values rather than value, which we do with an equation. But other than that, it's essentially the same thing. Keep in mind these things though. Inequality signs will change when you multiply or divide by a negative number. How I remember it is this way. If you change the sign, you change the sign. Got what I'm saying? You change the sign of the number, then you change the inequality sign as well. So if you change the sign, you change the sign. The other situation which people often forget, and you don't do it that often to be honest, but if you take the reciprocal of both sides, that will change the inequality sign as well. Because think about it logically. 2 is less than 3, but if you turn it upside down, it's not true to say a half is less than a third. So you would need to change that sign. I'll say, it's not that common we do that. Let's start with something very simple. 6x is less than 36. So we divide both sides, there's our answer. Often with these, we put the solutions on a number line. So how would I put this one on? Well, I'd circle the 6 to show it's not included, and then I'd draw an arrow, but my arrow is just above the line. Okay, we have ones where there's actually more than one side. Unlike equations where you usually don't have 2 sides, we can have 3 sides to an inequation. But the rule's still the same. Whatever you do to one thing, you do everything. So we move the 6, divide by -4, but if you change the sign, you change the sign. You never leave it like that, because that's just ugly. Whew, that's better. Okay? And if we were to plot that on the number line, it would look something like that. Which now brings me to the correct way of writing an inequality. Your algebraic solution should match the geometrical solution. They should look the same. So something like that is x is greater than 5. It is not 5 is less than x, because what you are finding is the subject. So you're saying x is greater than 5. If you say 5 is less than x, I'm going to go, well, that's fantastic, but what's x? All you've told me is 5 is less than x. Where when you say x is greater than 5, that's telling you x is always bigger than 5. So that's the way we do it. Something like this one, where it's in between 2 values. That's how I write it. Look, it looks like the picture. 4 is on the left-hand side, 6 is on the right-hand side. We don't write it that way around. 6 is greater than or equal to x is greater than 4. It's just ugly. And we certainly don't do something like that. X is less than 4 or x is less than or equal to 6, because that is just plain wrong. If you tell me x is greater than 4 or it's less than or equal to 6, I claim that everything is a solution. How about this one, when it's either side? Again, look, it looks like the picture. You've got x is less than or equal to 4, the less than or equal to sign's going to the left, just like the arrow there. X is greater than or equal to 6, arrow going to the right, just like the greater than or equal to sign. That's how we write it. Not like that, just with the inwards point. No. Looks horrible. I've even seen people try and do that. 4 is greater than x is greater than or equal to 6. Again, that one's just plain wrong. That's me being fussy, but that's how I want you to write them. Quadratic inequations then. So linear ones we've dealt with. We have a quadratic. The temptation is to do it exactly the same as an equation, which we sort of can to start off with. In other words, I'll factorise it. It would now be a mistake to treat it like an equation and go, well, that means either x plus 6 is less than 0 or x minus 1 is less than 0, because again, that's not correct. Because we're basically saying 2 things multiply together to give a negative number. One might be positive, one might be negative. Which one is which? Don't know. So you could think of it graphically. Now, whether you physically draw it or just think about it, we know the parabola y equals x squared plus 5x minus 6 would have x-intercepts at minus 6 and 1. If I drew the parabola in, it would be concave up. So the question really is saying, what values of x is the parabola below the x-axis? When is it less than 0? It's all those points underneath the axis. But of course, I'm only interested in the x values. I don't care about the y values. And so it's those ones, in between minus 6 and 1, it's below. There's my answer then. Minus 6 is less than x is less than 1. Let's try another one. I hate factorising negative quadratics, so I'm not going to. But if you change the sign, you change the sign. So I've changed it to x squared plus 3x minus 4 is greater than or equal to 0. That factorises nicely. If I was to draw that one up, x-intercepts at -4 and 1. Both points are included this time. Concave up, but this time I'm saying, hey, when is this parabola above the x-axis? Again, I'm only interested in the x values. So therefore, I'll be on either side. X is less than or equal to -4, or x is greater than or equal to 1. Now what you'll find with quadratic inequalities, it's either going to be in between the 2 points or on the outside of the 2 points. Has to be. Because if you think about it, you're drawing a parabola. So it's either going to be between or on the outside. It could be one of those cases. So what you could just do is solve the equation as normal. That will get you the critical points, the boundaries, and then test the regions in between and see where it works. Well, what about an absolute value inequation rather than an equation? Absolute value of x plus 5 is less than 2. Now this is where using the definition makes life a lot easier, because either x plus 5 is less than 2 or the negative of x plus 5 is less than 2. You see, what a lot of people do is they'll go x plus 5 is less than plus or minus 2, but this is not true. So their inequality sign gets mucked up. Doing it via the definition, you don't muck up your inequality sign. So the left-hand one, x is less than -3. The right-hand one gives me x is greater than -7. Both have to be true, so therefore I must be in between -7 and -3. Let's do the next one. Okay, either 3x plus 2 is greater than or equal to 1, or the other possibility, of course, is -3x plus 2 is greater than or equal to 1. So we solve that one, minus a third. Then the second one, -1. We plot that one. And I hope you'll agree with me that this turns out to be an OR situation. You could do it a different way. You could turn it into, I'm not suggesting you do it this way, by the way, but you could turn it into a quadratic. That's the same question here. Absolute value of x plus 5 is less than 2. If we square both sides, and I can do that because squares are positive and absolute values are positive. Now, I get x plus 5 squared is less than 4. Because when you multiply inequalities together, the inequality is preserved in this case, because we're dealing with positives. So this works. We turn it into the quadratic. And so we're in between or on the outside. We don't know which yet. Okay, we end up with the situation where our parabola is below the axis. So with the second one, again, I could square both sides. I end up with this quadratic. Once again, we have the same answer. Some people do it that way. Personally, I don't, but there's a method you could use. Inequations with the pronumeral in the denominator. Start with a very simple one. 1 over x is greater than or equal to 3. The most successful method is what's called the critical points method. And this is the critical points method. First of all, let's work out what makes the denominator 0. That's a critical point because the bottom of a fraction can't equal 0. Let's find it. In this case, of course, it's just x can't equal 0. Then we forget the fact that it's greater than or equal to. We just solve it like a normal equation. 1 over x equals 3, so x is a third. That creates a second critical point. Now, I just test in between my critical points and see what works. Now, you wouldn't necessarily write this down. A lot of it's done in the head, but okay, I'll check -1 to see what happens. Sub that in, I get -1 is greater than or equal to 3. No, it's not. So -1 can't be a solution. I'll test a quarter, because that's in between 0 and a third. Sub that in. 1 over a quarter is greater than or equal to 3. Yes it is. So I know I'm in between. And let's do the right-hand side. We'll test x equals 1. 1 is greater than or equal to 3? No, it's not. There's my solution. X is in between 0 and a third, but not including the 0. So let's try another one. 2 on x plus 3 is less than 5. Oh, well, I know x plus 3 can't equal 0, so there's my first critical point. X can't equal -3. Solve it like an equation. And I get, there it is, x equals -13 on 5. Draw it up, test in my head. Well, let's see, I'll work out 0. Does 0 work? 2/3 is less than 5. Yes, it is. But anyway, we end up on the outside. So the solution to the equation is included in the first one, because equals 2 is what I solved, whereas it's not included because it's just less than 5, not equal to 5. So bottom of the fraction, that one is always not included. The other one depends on whether equal to is part of the solution or not. I say, this is the most successful method. Here's what most tutors show you. They would like you to turn it into a quadratic inequation. This is probably the most common method, not the most successful method. We will multiply both sides by the denominator squared. That makes sure it's a positive number so the sign won't change. So we end up with x is greater than or equal to 3x squared. 3x squared minus x is less than or equal to 0. Okay, let's solve it. And we've got 0 and a third. So why do I say the other method's better? Because in the other method, I was solving a linear equation. In this method, I have to solve a quadratic equation. Now, a linear equation is always going to be easier to solve than a quadratic equation. And what is always forgotten here, this is where the mistake comes from, is the domain problem. You see my final answer there? It's not correct. X can't equal 0 because of the bottom of the fraction. So that should be my answer. Let's try the other one. Multiply by x plus 3 squared. By the way, if you are using this method, for goodness sake, don't expand out at this stage. They do have a common factor of x plus 3 there. No, don't expand out only to then have to factorise. So x plus 3, 5x plus 13, and we get our solution. But remember, x can't equal negative 3. Now on this one, not an issue, because we didn't have it equaling negative 3 anyway. There it is. Okay, exercise 5A.